I want to start here talking about higher order derivatives and specifically the notation for higher order derivatives. What do I mean when I say higher order derivatives? What am I talking about? No? Yeah. So it's taking the derivative more than one time. So we start with this function, we take a derivative, and then when we have that derivative, we take the derivative again. That's called a second derivative. And then we could take the derivative of the second derivative, and that would be called the third derivative. And then we could get the fourth derivative and fifth derivative and so on. Depending on what kind of function it is, it might be kind of trivial once you get to a point where the derivative may just go to zero, the higher order derivatives. Sometimes they'll get a pattern with the derivatives, and all kinds of things can happen. Okay, so what I want to really hit on today is what the notation looks like when we're talking about derivatives beyond the first derivative. We'll start by reviewing the first derivative. So if we have this function, if we have a function y or f of x, how do we write the derivative of that? Let's start with Leibniz notation, which is using the d's to represent differentials. How would we write the derivative of y with respect to x? dy over dx, which is the same thing as saying the derivative with respect to x of the function y. Okay, so either one of those would be Leibniz notation for writing the derivative of the function y with respect to x. This one is just a little bit more compact because it puts the y in the numerator with the differential. Okay, how about using the functional notation, or we could even do this with the y part, but what other way do we write the derivative? Could say f prime of x. Okay, and so any one of those three, and actually I'll put another one on there too, y prime, any one of those four would be a way of writing the derivative of that function. Okay, those are all first derivatives. Second derivative, this notation is really easy. How do you think we're going to write the second derivative? Yeah, add another apostrophe, another prime. So we could say it in a few different ways. Usually we say f double prime of x if we were going to read it, or y double prime. This way is not as easy. So I'm going to kind of do a little scratch work here at the bottom to show you what's going to happen. So the second derivative, what we're doing is we're taking the derivative with respect to x of the first derivative, which is the derivative with respect to x of y. And we treat this as a multiplication problem, basically. And so we multiply d times d, and that would be what? What's d times d? D squared over dx times dx is dx squared. So the second derivative could be written like that, or it could be written like that. And this notation is a little bit confusing sometimes. And a lot of people write it incorrectly sometimes. So it's really important that you understand the difference between that and this. They mean completely different things. Okay? And the difference is what? You guys tell me the difference. The derivative of y squared with respect to x. I mean, sorry. Don't tell me the difference in what it means. Just tell me the difference in the way it's written. Yeah, the square in the numerator is on the d here, the correct way, what we want to say, and it's on the y here. Okay? What this means is we're going to square the function and then do this calculus stuff on that. And actually, it doesn't have much meaning because we have one differential on top and we have a squared differential on the bottom. And so it doesn't really mean anything. It's kind of nonsensical. So you have to really make sure that you use the correct notation when you're doing the second derivative, or that you recognize the correct notation. That if I were to write something like this, or something like that was in the book, you would know what it means. Okay? Now, with that, I think you could probably tell me what the third derivatives are going to look like. Anyone want to give it a shot? Using this notation first? Okay, which is the same thing as saying this. Which is the same thing as saying f triple prime of x or y triple prime. Okay? Any questions about this? Now, yes?
Why doesn't the d have a power too?
Because, and technically what's happening here is we're taking this whole differential, the dx, and cubing it. But we don't have to write the parentheses there. But both of them are being cubed together. Does that make sense? Good question. Okay. Now, as you can probably imagine, I said earlier we can take the derivative really as many times as we want, as long as it's a differentiable function. So I could take the 7th derivative, or the 17th derivative, or the 100th derivative of something. Obviously, this notation lends itself a lot better to taking many derivatives than this one does, because I could write d to the 100th y over dx to the 100th a lot easier than I could write f with 100 primes after it, and also look at it and know what I'm talking about. So we have to come up with a different notation for this once we get to higher numbers where we don't want to write 5 primes or 7 primes or whatever. Yes?
If it was like the 100th derivative, would you have to like calculate every derivative in between 1 and 100?
Possibly, but usually not. And the only time we would get to anything like finding the 100th derivative of a function would be later on when we're doing Taylor and Maclaurin series. And if we're going to do that, there's going to be a pattern. We'll do that for something like the sine function. If we're taking the 100th derivative of the sine function, there's a pattern, and it starts repeating. And you could use that pattern to figure out what it is rather than taking the derivative 100 times. Okay. I would never actually make you do that.
Okay.
That would just be kind of mean. So anyway, let's say I did. I wanted you to find the 100th derivative of something, and you want to use the prime notation. You can still do it, but you're going to write it like this. Sorry, a little delayed here. So the 100th derivative, let me write it in Leibniz notation first. Sorry for the sloppy handwriting. So we would write it like that in Leibniz notation, and like I said, that's pretty straightforward, that's easy. That's the same thing as saying f now, it looks like f to the 100th power, but it's not. Do you guys need to get going? This is another difference that we need to distinguish here and make sure you don't get confused on notation. This does not mean the same thing, and let me write it this way also. This does not mean the same thing as y to the 100th power. And it's a subtle difference, but we have parentheses here and we don't have the parentheses here. The parentheses tell us that we're taking the derivative. Okay, so in this case we're taking the derivative 100 times. Now that might sound a little ridiculous, and we're probably not going to do it 100 times, but even if we're doing it like 4 times, we're taking the derivative 4 times, we would write that derivative as f to the 4th in parentheses of x. Now here's where it's more useful. Not necessarily this way, but let's say we don't know how many times we want to take the derivative yet. We're going to take what's called the nth derivative. So we're going to take the derivative n times, and this is just generalizing how many times we're going to take the derivative or what the derivative is. This is going to be something that's useful when we start doing the Taylor series stuff. and I know you guys are really excited about that, aren't you? As much as I'm talking about it. We would write it like this. Or like this. Or like this. And what this just means is the nth derivative. Does that make sense? That sound fair? And the main thing here is I want to make sure that when you see this notation, or if you would have to use this notation in your work, you would know what it means.